Hi folks, today we're doing section 3.2 called Solving Systems Algebraically. On 3.1 last week we looked at solving systems of equations by graphing them and finding the intersect. So today we're going to add like another tool in order to solve, and that's algebraically. There's two types. If you notice our objective is to solve a system of equation by substitution. Oh, that's supposed to be a highlighter. By substitution, and then the second one is elimination. Today is our substitution day. There are different times when these different tools, like graphing, like in 3.1, substitution like we're doing today, elimination like we'll pick up tomorrow, where one is a benefit over the other. So today we're focusing on substitution. Substitution works really well if we have two equations and one of them has a variable that's already isolated or really close to being isolated. So in this case, we're going to solve by substitution. We have our system of equations of 4x plus 3y equals 4 and y equals 2x minus 7. So substitution means exactly that, and where is if this is what is equal to y, I am literally going to replace the y or substitute it out for my 2x minus 7. So my equation is now 4x plus 3 times the quantity 2x minus 7 equals 4. When I substitute, I always plug this in within parentheses because my 3 is multiplied by that entire quantity. So then my next step would be to distribute. And my equation now is 4x plus 3 times 2x would give me 6x, and 3 times a negative 7 is a minus 21 equals 4. And now from here, I have only one variable, x's, so I'm going to solve and find what x is. Combining like terms, 4x and 6x, since they are on the same side of the equal sign, I'm literally just going to add them to get my 10x minus 21 equals 4. Then from there, add 21 to both sides. And I'm coming up here with my equation. So 10x is equal to 25. Divide by 10. And x is 2.5. Oftentimes I'll have students stop there because then they have x equals a number and they're like, good, I'm done. But we're trying to solve a system, and if you remember from 3.1, systems of equations, their solutions are an intersection with an x and a y value. So we have the x, 2.5, but we still need to get this y. So what I can do is I can plug in x equals 2.5 into my original y equation for x. So y equals 2 times 2.5 minus 7, which 2.5 minus 7, or I'm sorry, 2 times 2.5 is 5, and then minus 7, and I get my y is negative 2. So my solution would be the point 2.5, negative 2. I'll give you a second if you need to get caught up. Example number 2. Again, solving by substitution. This one looks a little different though, in that I don't already have my y all by itself like I did up here. So if I'm going to solve by substitution, the first thing I need to do, since it's not done for me, is get one variable all alone. So it doesn't matter which you do, x or y. Since we had y alone here, I'm going to get x alone here just to switch it up. So to solve this to get x by itself, I subtract y from both sides. This cancels, and I have x equals negative 12 minus y. Now that I have a variable all by itself, isolated, since x equals negative 12 minus y, I can literally take that and replace my x in my first equation out. So my equation now becomes 2 times the quantity negative 12 minus y, close my parentheses, and then minus my 3y equals 6. Be careful on your negatives in here. So my next step would be distributing. Don't lose these though. So 2 times the negative 12 gives me negative 24. 2 times negative y would give me minus or negative 2y. It still bring my minus 3 down, and that's equal to 6. Then I'm just solving an algebra problem. So combine like terms. Negative 2 and negative 3y. So I have negative 24, that didn't change. Negative 2 plus a negative 3 would give me a negative 5y equals 6. Add 24. Those cancel. Negative 5y equals 30. Then last step for solving for y, divide by negative 5. And my y equals negative 6. So found my y, negative 6. Almost there. Need the whole point though, so I need the x. So what I do is I take the y I found, and you can really plug it into any of these equations where the y is and solve, but I find it pretty easy to go, since this is already solved for x, let's plug it in right here. So my x is equal to negative 12 minus, and then right in for my y is my whole negative 6. So minus a negative 6. So what happens here? Negative 12. Well, if I minus the negative 6, that would change to a plus 6. Negative 12 plus 6 is the point, negative 6. So my x is negative 6. Making my solution negative 6, negative 6. You need to write your solutions as these coordinate points. Last example today, just 3 because we're splitting this up into 2 days. We'll do elimination tomorrow. So example 3 is still a substitution problem, but this one's in a context. So we have to create our system of equations first. They're not just given it to us. So at Rinaldi's Pizza, a soda and 2 slices of pizza of the day cost $10.25. A soda and 4 slices of pizza of the day costs $18.75. Find the cost of each item. Okay, so if I'm going to come up with a system, I need an x and a y variable. They give me this relationship in terms of sodas and pizza and how much that costs. So I'm going to consider my soda is my x and my pizza is my y, and I'm going to write my system. So my system, first relationship, 1 soda, so 1x, and you do not need to write the 1, but you may, plus 2 slices of pizza, 2y, equals $10.25. Second one, 1 soda, so again, just an x, and this time I'm going to write it without the 1, and 4 slices of pizza, plus 4y, costs $18.75. Find the cost of each item. So I want to know my x and my y. So substitution. First thing I need to do, get one variable alone. It doesn't matter which equation I use. I'm going to use the top one because it's a smaller number, and I just like to work with smaller numbers if possible. So this is 1x, which is the same as just x, so I'm going to change that to x. And I'm going to solve for x. So first thing I would do, well, let's move this to y. Since it's positive, I would subtract 2y from both sides. That cancels, and I have x equals negative 2y plus 10.25. Now that this is solved for x, a single variable, I can take this and substitute it in for the x in my other equation. I can't go back into here because then things will just cancel and I won't get an actual y. You have to go into the x for the other equation. So you have to go into the x for the other equation. So I am substituting in here and replacing that x. So I get negative 2y plus 1025. I didn't put this one in parentheses because this isn't multiplied by anything, so I don't have to worry about distributing it to both terms. And I have my plus 4y equals 1875. From there, I'm combining like terms, so I have a negative 2y and a 4y, so that would be negative 2 plus 4 is positive 2y, plus my 1025 equals 1875. Solving. Subtract 1025 both sides. This cancels. I'm going up here with my equation. 2y equals, well, 1875 minus 1025 is 850 divided by 2, and y is 425. So in this case, y represents my pizza of the day, so I'm going to label that, and I'm not going to worry about putting my answer in a coordinate point, because this is more a system used for context, and we're more concerned on, okay, pizza of the day, oh, pizza of, not cost day, pizza of the day costs $4.25. Once I have my y, I can plug that back in to the y of my equation that's solved for x. You could plug it into either one of these. I like to do it here though, because then it's just a simple multiplication and addition problem, and I don't have to move anything from the left or right side of the equation. So plugging that in, my x is negative 2 times 425 plus 1025 negative 850 plus 1025. So my x, or a soda, cost $1.75. So that is solving systems of equations by substitution. You have your homework problems already on the schedule that I handed out, so please reference that. Homework is on page 128, and I will see you all tomorrow.